I would like for you to turn your exam in on Monday, which is the 11th. So turn it in class. So you're just working on that as a take-home test. It's okay to get help from other people. Please get help from me first before talking to a tutor or work with each other. I've got questions that are similar to your test questions. Okay, so the first couple of questions ask you to find the equation of a tangent line to a function at a point.
We're reviewing the exam.
We're doing examples to help you with your exam.
So they're not necessarily the same questions, right?
No, not, they're similar but different, not quite the same. Okay. I'll be right back. So find an equation of the tangent line to the function h of x being 4/1 plus x squared. Okay. At the point, -1, 2. And I've also written these questions and I'll scan them tomorrow after class and then they'll be posted to Canvas. So there's going to be a copy of all of these problems. Okay, cool. And h prime of x will give you all of the slopes that you need for tangent lines along the function at any point, and then we'll plug in the x value for this specific point to get the tangent line right there. So let's get h prime of x first. I'm going to write down what I just explained. We're going to get h prime of x so that we can find h prime of -1. And that's going to give you the slope of the tangent line at the spot where you have x equal to -1.
The one comes from the x-axis, right? At the point.
Yeah, at -1 for x, and then it would go up to 2 for y, but we can just use this part. And you're getting your slope of your tangent line at that spot. Okay, h prime of x. I'm going to use the quotient rule. So I'm going to call this numerator, the function f. In the denominator, you have some function g. We want f prime g minus g prime f divided by g squared. Okay, f prime is going to be 0. Multiply by 1 plus x squared. Subtract g prime. Okay, derivative down here is going to be 0 plus 2x. Multiply by 4. Divide by the denominator squared. 1 plus x squared squared. Let's see, 0 minus 8x. Okay, what we'll want to do is substitute x equal to -1 through h prime of x to get the slope of the tangent line when you've got x equal to the slope of the tangent line to the function where x is equal to -1.
Wait, where did you get the 0 from? Where did you get 0? Wait.
It was the derivative of the number 4.
Yeah, wait, 4x though, or what, or wait, is the derivative of 4x, right? Or did you just like replace 0, is it x with 0 or something?
We'll put the function back over here, and then we'll kind of see. It was h. Okay, and then we call this f,
Oh wait, okay, yeah.
and then you get this.
My bad. I was looking at something else.
Okay. Okay, we're here, putting in x equal to -1. So -8 times -1. Put over 1 plus -1 squared. Okay, 8 over 1 plus 1 squared, so add a 2 squared. So you get 2. Okay, 2 is your slope. And I'm going to put up the general equation of a line, and then we're going to get information to get that tangent line.
Yeah.
Okay. You could use y equals mx plus b, or there's the version y minus y1 equal to the slope times x minus x1. Okay, so if you put information from the scratch work in here, you're going to get your tangent, your equation of your tangent line. As y minus, what was the point? I think it was 2. Y minus 2 equal to the slope, which was also 2.
Just the two of us. I feel alright. Just the two of us.
Andy,
You
I
and
can't get you
I'm
on
sorry.
mute, but you can unmute if you need have a question. Oh, thank you. Alrighty, we're gonna write this up a little bit nicer. but we've pretty much got the answer. Minus 2 equals 2x plus 2. I know that you may have seen problems like this and jumped right to an answer, but sometimes people make mistakes if you don't actually write your scratch work out. Saw it happen last time I taught this class. So just go through the motions, make sure you add 2 to both sides, and get y equals 2x plus 4. I had I think like the same question for students the last time I taught this class, and a lot of people put y equals 2x and he just cancels out the 2's. So just be careful. Okay, another question like this. Find an equation of the tangent line to the function. Okay. Okay, f of x equal to x cubed plus 2e to the x. At the point 0, 2. Okay, if you get f prime of x and then plug in x equal to 0, you'll get the slope of the tangent line to this function at that point. So we want f prime of 0. But we're going to start with getting f prime of x, which will need a product rule, and this is just like a log rule, nothing crazy. Okay, I hope I said power rule. I meant to say power rule. We're going to bring 3 down and have x squared plus 2 e to the x. Okay, so f prime of x gives all of your slopes of your tangent lines at any of your points for this function here. But we want to go right to that point, so we want to have x equals 0. And we'll get the slope of the tangent line at that point, 0, 2. Zero cubed. Add, oh, wrong. We're here. 3 times 0 squared. Plus 2 e to the 0. 0 plus 2 times 1. So I got a slope of 2. And our equation of our tangent line will have a slope of 2. Then you put in your values from your point. This is my x value, there's my y. Okay, y minus 2 equal to 2 times 0. Oh, x minus 0. All right, y minus 2 is equal to 2x. So y would be 2x plus 2. Okay, another problem where we're going to get the full equation of the tangent line to a function at a point. Okay. Y is equal to 2 ln of x plus x squared minus 1. Okay, and we're at the point 1, 0. Okay. If we get f prime of 1, you'll have your slope of your tangent line to that function at that point. Okay, f prime of x first. Okay, well, we have 2, so the 2 sits there. The derivative of ln of x is 1 over x. So 2 times 1 over x. And then we're here, derivative is going to be 2x. And then at the end, you subtract 0. Okay, here's our point. Your x value is 1, so put or sub in x equal to 1. Find f prime of 1. Or 2 over 1 plus 2 times 1. 2 plus 2, which is 4. Okay, our tangent line looks like y minus 0 equal to the slope 4 times x minus 1. sweet. So y equals 4x minus 4. Okay, we're going to switch it up just a bit, and we're going to find derivatives of functions. And make sure we talk about the quotient rule, the product rule, the chain rule. We're going to just like make sure we practice derivatives. Find the derivative of f of x equal to in parentheses we have x cubed minus 3x plus 8. And at the end we have a power of 6.
We're using chain rule for this one, right?
Yeah, for sure. So f prime of x equals, okay, that's the chain rule first. Okay, outer function, we'll bring down that 6, leave everything inside alone, and then remove 1 from the power. Um, okay, here with this, okay, this is all copied down. There. Okay. Then go in here to the parentheses, take the derivative of what's inside, which would be 3x squared minus 3. All we're going to do next is factor out that 3, multiply it with this 6, and then this should look good. All right, again, factoring out that 3, so we've got 18 times x cubed minus 3x plus 8 to the 5th. Times x squared minus 1. Okay.
Well, where did the 18 come from?
Factor out a 3 right here, and then multiply it up front with that 6.
Oh wait, you took the, you simplified the second equation. You like divided by 3.
Here, we'll write an extra.
It's same thing as 3. Yeah, it's same thing as 3 times x squared minus 1, right?
Yeah.
Okay, I think I see what you did there.
Okay. Here we go. Find the derivative of f of x equal to. Okay, we're going to do cosine of tangent of x to the fourth. I think we'll need space. Okay, so again, we're going to use the chain rule. Yeah. Okay. Sine of x is okay. Outer function is cosine of x. Derivative of cosine would be negative sine of the stuff inside, which is tangent of x to the fourth. Okay, that's that part. Then we're going to go inside. The derivative tangent of stuff is secant squared of that stuff. So secant squared of x to the fourth. Okay, that's that part. Inside, we have another function, x to the fourth. And then its derivative is for x cubed. You could leave it like that if you want to. I thought it was nice to put that 4x cubed up front, and I wrote negative 4x cubed times all this. It's the same thing. Okay. This will be fine. All right, we've made it to getting the derivative of. Y equals 8 to a power of 4 minus x to the fifth. So you do have a chain rule. Your outer function being 8 to some power. But in that power, you have a function 4 minus x to the fifth. So we'll start with the derivative of the outer function, 8, 8 to a power. So you just copy this down, 8 to the power of 4 minus x to the fifth, but then multiply by ln of that number base, 8. Okay. Now that's the derivative of the outer function. Go up into the exponent where you've got your inner function, and that derivative would be negative 5x to the fourth. Well, 0 minus 5x to the fourth. Okay, and then I just put the 8 and the I put the ln of 8 in the front, and I also put that 5x to the fourth in the front because it's easier to read. But it's just really the same thing. Oh, negative 5x to the fourth.
Wait, is that negative, right?
Yeah, and it's negative. There's a negative.
Yeah, the 5 is negative. Yeah, negative 5.
That part, ln of 8, and then there's that 8 with power 4 minus x to the fifth. We want to differentiate. F of x equal to 8 sine inverse of x squared minus 1. Okay, so we're going to just start with, you have a number times this, so just leave that number there. 8. Okay. Derivative of sine inverse of that stuff. So derivative of sine inverse would be 1 over the root of your 1 minus that value squared. So we want 1 minus that thing squared. And again, what goes in here is whatever you're inputting into that sine inverse function, x squared minus 1. Okay, so we've got that there. We've taken care of this part here. You need to multiply by the derivative of the inner function, which would give you a 2x. I'm just going to write it right in the numerator right here. So then you would want to multiply using the chain rule by 2x. Okay, so we have 16x over the root of x squared minus 1 squared. And I'm just going to leave that root how it is. Well, you can simplify what's under the root, or you can just leave it. It's fine. I wouldn't mark it down if you just left it like this. Got 15 minutes.
Wait, what does it mean by differentiate, by the way?
Differentiate is the same kind of thing as find the derivative of.
Okay.
Yeah. Let me see. You could Google it too. We've got some time. It means let's see, math. In mathematics, the derivative of a function is a blah, 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 blah. Derivatives are fundamental. It means finds the derivative of. Let's see, we can get a better. Differentiation is a process of finding a function that outputs the rate of change of one variable with respect to the other variable. or outputs the slopes of the tangent lines to that function. Okay, we've got a function, and we're going to get its derivative, and we're also going to get the second derivative. Okay, our function is e to the x over x. And second derivative of f with respect to x, f double prime of x. Okay, we're using the quotient rule. So I know we already have the name f, but I've just like memorized the quotient rule using the letter f and g. So I put f in quotes, but it would probably be better to pick a different letter. Okay, just to be. How do I want to do this? I know how to do this. So you're taking the derivatives of what's in the numerator. Multiply by that denominator, x. Okay. Then subtract taking the derivative of what's in the denominator. Multiply that by the numerator, e to the x. And then divide by that denominator squared, x squared. Okay, derivative of e to the x is e to the x. And then times x. Derivative of x is 1. Multiply that by e to the x, and then it's over x squared. What I'd like to do is factor out e to the x in the numerator, which would leave e to the x times x minus 1. Okay. And get f double prime of x. So first, we're looking at a quotient rule of that function in the numerator over the one in the denominator. But also when you go to take this derivative here, there's a product rule. So quotient rule first, product rule next. From the quotient rule. You want to take the derivative of the numerator, then multiply by the denominator. Okay, then subtract, taking the derivative of the denominator multiplied by the numerator. I don't have enough space. I need to copy this down. So I'm just going to copy paste. Okay, then divide by the denominator squared, which is x squared squared. Okay, then here we're doing this derivative and we're taking it's a product of two functions. So with the product rule, you want the derivative of the first function times the other, add the derivative of that function times that first function. So f prime g plus g prime f prime, or derivative of e to the x is e to the x times x minus 1 plus derivative of x minus 1, which is 1, times e to the x. And there's a multiply by x squared outside there. And a subtract 2x times all this. E to the x times x minus 1. Correct. Cool. In the square brackets, there's an x e to the x minus e to the x plus e to the x. So those last two terms are going to cancel. Or add to 0. Space. X e to the x minus e to the x plus e to the x squared. That's 2. Actually, we're gonna back up and we're going to distribute this 2x e to the x to that x minus 1. All this multiply here and then there. Negative 2x squared e to the x. Okay, and then positive 2x e to the x. And then you've got that negative e to the x, positive e to the x, it's going to be 0. Okay, we're getting there. X e to the x. Times x squared. Which would be, we're gonna have x cubed times e to the x. Minus 2x squared e to the x. Plus 2x e to the x, and then we'll factor out x e to the x. Okay, we've got x squared minus 2x plus 2. And it's all over x to the 4th. And then that x in the numerator is going to make that power reduced by 1 in the denominator. So we've got e to the x times this over x cubed. Nice. Oh no, I ran out of time. Okay, I have 2 more examples, which, again, I've written them up on paper. We can just do them in class tomorrow, and then we'll keep on doing notes for 4.1. Okay, so we're done for today. And also,
Have a nice day, Cassie.
yeah, have a nice day. Bring questions if you have questions, and we'll go over them in class tomorrow.